All right, welcome to Unit 7 for PCM. This is 7.1, Matrices and Systems of Equations, and this is day 1 of our notes for section 7.1. First thing we have to do with matrices is learn how to classify them, known as the order of a matrix. So the order of a matrix is determined by the number of rows across and columns up and down. So for example, on this page here, we have a 3 by 2 matrix. Reason for that, again, 3 rows across, 2 columns up and down. So this is be classified as a 3 by 2 matrix. Again, rows always first, columns second. If the number of rows and columns are the same, we refer to that as a square matrix. So you notice this first one has 2 rows across, 2 columns up and down, so that is a 2 by 2. And the second one here is a 3 by 3. So again, anytime you have the same amount of rows as columns, that's a square matrix, whether it's a 2 by 2, 4 by 4, 8 by 8. We won't deal with anything that large, but if you had 8 rows and 8 columns, that would still be a square matrix. Okay, an augmented matrix. This is a way for us to take a system of equations and change them into matrices. And so I'm going to show you how to do this on this slide. Notice we have 3 equations here in 3 variables, x, y, and z. And then we have what each equation equals. And in this case, the top equation equals 5. The middle one equals -3. And that third equation equals 6. When we do an augmented matrix, we just take the coefficients. So in the first matrix, notice we have 1x, -4y, and 3z. We just write those coefficients right here, 1, -4, and 3. And then we have this little vertical dotted line and what the equation equals. So in this case, it equals 5. We'll do the same thing for the next equation, -1x, 3y, -1z, equal to -3. 2x, 0y, -4z, equal to 6. What this augmented matrix allows us to do is solve this system of equations. We'll get into that in a little bit. From an augmented matrix, if we don't care about what they equal, we can just do what's known as a coefficient matrix. So notice the difference between these two is we don't have what the 3 equations equal. We just have the coefficients for x, y, and z. So augmented matrix, you use the entire equation. Coefficient matrix, just use the coefficients on your variables. All right, so write the system of equations given by each augmented matrix. So here they give us the matrix. We only have 2 variables here, so you could use A and B, C and D, use whatever you want, but I'm going to use x and y. So 5x plus 4y equals 22. -3x plus 2y equals 8. So we can go back and forth. They'll either give us equations, ask us to write the augmented matrix, or they'll give us the augmented matrix, ask for the system of equations. Similar deal here on the bottom. So we got 1x minus y plus 4z equal to 13. 2x plus 3y plus 5z equal to 47. -3x plus 7y. There is no z term. You could write plus 0z, but I'd usually just skip it if there isn't one, equal to 21. All right, elementary row operations. This is referring to the rows in a matrix and what we can do with them. So there's a couple rules that we have to abide by when we start switching these matrices around to solve them. The first one is we can interchange any row we want. So if we want to move the top row to the bottom, move the bottom row to the middle, move to the middle to the bottom, we can change the order of any row we want at any time. So that is allowed. We can also multiply any row we want by a number as long as it's not 0. So if we want to multiply a number by 3, we can. If we want to multiply it by a fraction or a decimal, we can. The only thing we can't multiply it by is 0. And then the third thing we can do, we can add rows or a multiple of a row to another. So for example, I could take the top row, multiply everything in that row by 5 and add it to the middle row. That's allowed. Or I could just add the top row and middle row. That's okay as well. So we'll use these two a lot. Every once in a while we'll switch the order, but generally we'll use these 2 steps here for elementary row operations. So in this particular problem, we're going to show you what we did here. So it's going to say fill in the blanks using elementary row operations. And so what would happen on a typical homework problem is you would see the first matrix here and then the second one. The difference is you wouldn't have this number here. So that 2 would not be there, just be a blank. So the key is, how do we get this row from 2, 10, and 5? How do we get it to 0, whatever this number is, and -1? So you know the answer is 2. I'll leave that there for now. But how did we get from here to here? Well, if I multiply this row by 2, actually it'd be -2, excuse me. So if I take -2 times this top row, I'm going to get -2, -8, and -6. Now, why would I do that? Well, if I multiply this row and get -2, notice what happens when I add it to this bottom number. So -2 plus 2 would give me 0, which is this first number. -2 times 4 is -8. -8 plus 10 is 2, so now you know where that one came from. -2 times 3 is -6. -6 plus 5 is -1, which is this number. So again, just to show you what we did here, I multiplied the top row by -2, added it to the bottom row, and that gave me this result. Now, rather than write this out as -2 times row 1 or no change, we just do this right here. So this is telling me -2 times row 1. So I multiply this by -2 and added this row to it, and that's how I got this result. So again, on your homework today, you'll see a couple problems like this. They'll give you a starting matrix, they'll give you an ending matrix, and you have to figure out what did I add or what did I multiply to get from the starting one to the ending one. Okay, again, this is just a review of writing an augmented matrix given equations. So notice I took the coefficients here, 7x, -5y, 1z, and that equation equaled 13. Bottom one, 19x, no y's, -8z, equal to 10.